Hey guys, I just want to walk through a couple of methods that we have available in the Pod 10 environment to stand up a quick OpenStack environment. So we're going to be using PackStack, which enables us to get a very quick environment up. We can use PackStack for multi-node installations, including controllers on some systems and computes on others. But for the migration factory environment, we really only care about having single target environments to migrate other VMs onto. So I'm going to walk through what I have documented to enable you guys to get up a very quick environment. Now, we will get to a point where we can select what version we're going to be installing. The rest of the procedures are going to be very, very similar. Some of the older versions of OpenStack don't have some of the features in the UI that I'll be demonstrating, but I will have documented how to do that from the command line. Okay, so very quickly, when you get a system, we're going to SSH in to the provided IP. In this case, I'm using this HP Blade 08. The first thing you want to do is take a look at your networks. So just kind of understand what's going on. I'll provide all the details for the various networks, but we essentially on these blades have two interfaces. So we've got provisioning, and then we have a secondary interface. Now, provisioning is just a name that Cobbler has given this interface. If you look underneath in the details, this is actually an ENP3S0, but Cobbler has renamed it provisioning. So going forward, anytime you refer to this interface, it is going to be the provisioning interface. And this is the IP you'll be SSHing into, and the gateway is going to be this 10.11.169.254. Now, this other interface, I've just given a 172.16 network. It does have some VLANs available that are routable, but for the purposes of a single environment, that doesn't matter. So I just gave it a very simple address that it can set up the tenant VXLAN networks on. If you did have a need for other compute nodes participating in this environment, just make sure that those are configured on this same network and that they can reach each other's IP address, and everything will work just fine. Okay, so we know what the networks are. So let's take a look at our repositories. So if I do a yum repo list, you'll see something a little strange down here. We have core 0, 1, and 2. Now, this is just a result of the fact that we're using Cobbler in this environment. There is a satellite server available. There is also a dedicated satellite server for the migration environment. Those can be used to register these systems to satellite, but what we have working as of this recording is a simple Cobbler environment. So this gives you the base RHEL RPMs as well as a couple of add-on channels. But because I want to cover the various versions of OpenStack you may be using, you will run into some dependency issues if you have these RHEL 7.2 repositories enabled. And for example, you try to install something like an older version of OpenStack, like OSP6, for example. So what we're going to do is use an internal engineering repository, or it's an RPM that enables repositories for different versions of OpenStack. So, of course, if you're doing this for a customer environment, you would use Subscription Manager to register upstream or to satellite server and so on. So let's start out. First thing we want to do is we're going to yum install this additional RPM. So I will provide the link to this in the documentation. This is an internal-only tool. It is extremely useful for situations like this, where we have a lab environment that we want to get a version of OpenStack up very quickly, and we don't want to worry about exactly how and which repositories we need to enable. So we simply enable this. This will use the core repos to install any dependencies that are missing once we enable the version we want to use. So we've installed ROS release, so we'll go ahead and take a look at it. If we just do a -- help, you can take a look at the various options. There are quite a few here. The one that looks interesting for us is let's take a look at what is available. So if I just do a -L, this tells you the available versions of OpenStack that this tool supports. So you can go back as far as 4. You can, those that may remember with version OSP5, we actually had versions for RHEL 6 and RHEL 7. So you can go back and choose that version. 6, 7, and 8 with the various installers available for each one. So I'm going to demo this on, we'll go ahead and just use 7 since it's nice and simple. Now we're not using Director, of course, so we'll just enable OSP7, the latest version. So that'll be ROS release 7. It's that simple. You'll see that as we took a look There are other options available to ROS release. You can enable some things called puddles. There's poodles. If you don't know what those mean, don't worry about it. It's essentially untested releases of the different versions. Okay, so we can see that some additional tools were installed, and these repositories were enabled. We take a look. So we've got our original core repositories, and then we have these additional repos that are necessary for the version we chose, which is OSP 7. Okay, one thing I will note is when using different versions, if you go back as far as 4, 5, or 6, a lot of those, as I mentioned, may have dependency conflicts with what are in the core repo. So the first thing we want to do is just go ahead and disable that. So I'm going to use the Yum Config Manager tool, and let's just disable all of these repositories. Okay, so another Yum repo list. And now we have a clean environment with these engineering repositories that are known and tested to work together. Okay, so next thing we'll do is go ahead and move forward with the Packstack install. One thing I do recommend is that you use terminal software that allows disconnecting and reconnecting in case you lose your connection. So there's something like Screen. I like Tmux, so we're just going to do that. Okay, so we have a Tmux session open now, and we're ready to move forward with the Packstack install. So we'll start out with install OpenStack Packstack, and that will have a number of dependencies. Okay, so the first thing we need to do is generate an answer file. So you can call this file anything you want as long as you're aware of what you're naming it and when you call it later. That's all that matters. So one thing that I like to do is go ahead and copy that file and keep that original file. That way we can always look at it and determine exactly what we changed and make sure we didn't make any typos, or just use that for reference for other environments. Okay, so let's go ahead and edit that file. So if you have not used Packstack in the past, there are quite a few of options. If we look at the bottom of the file, I mean, we have almost 1,200 lines of options, which of course there's a lot of comments in here, but that's quite a few options. If you run the Packstack command without an answer file, you will be interactively asked about all of these, and we definitely don't want to go through that. So I'm not going to explain every option. What I'm going to do is just jump down to what I recommend changing for a very simple environment for use in the Migration Factory lab. So I'm just going to use the password of Red Hat. Of course, you can use anything you want. I'm not exactly sure what features you guys need for your environment, so you can toggle some of these on and off. There are some, like the database server, Glance, that are required. But for the most part, some of these additional, like Manila, which is the file service, and even Swift, you may not need, but I'll go ahead and leave that on for now. But I believe you may need Ceilometer for some CloudForms integration. And I do recommend turning on Heat. By default, it is disabled, but it doesn't add too much overhead to the install to enable that. Sahara, I'll leave uninstalled, as well as Trove, Ironic, and so forth. So another change here, we want to add the NTP server. This is vital. Even on a single server, if you don't have an NTP server, Packstack will fail, and it does need to be able to contact that. I'm going to disable Nagios. We don't have a Nagios server to connect to, so we don't need to worry about that. And this section here would be where you would enable multiple additional compute nodes. So if you did have, for example, a different additional server you wanted to enable as a compute host, you could do that. We're not going to do that, though. In this case, this is essentially the three main roles. If you have used Packstack in the past, you may notice that these options are greatly reduced in the latest versions of Packstack. In the past, you could specify the target host for different roles, such as the database, AMQP server, MongoDB server, and so forth. They've really simplified that so that you have it down to these three choices. Okay, I'm going to start paging down now. There's a lot of options we can skip. We're not using VMware integration and a lot of these other options. So, and here are some of the additional hosts that I mentioned. They are still there. They kind of, as you see, there's an unsupported tag on these for customers who need this option during Packstack. Honestly, something like Director is a better option for some of the more complex installs. Nevertheless, we're going to leave all of these roles on this single system. Okay, we saw that we enabled the ROS release repository, so we don't need to worry about satellite, but you can use these options here to register to a satellite server. And one thing I will recommend is that you set your Keystone admin password to something, especially if you're going to be using these answer file as kind of a template for additional installs. Might as well set this to something known. Warning here, this is not secure or production style advice. This is just a lab use. We're going to ignore the majority of these options. What we're looking for next is the Neutron settings. Once we get past the Nova and the Nova Network, we'll start seeing these Neutron options. So there's Nova Network, which we're not using. Now we get into Neutron. Okay, so these are the vital changes to make these environments work properly within the Pod 10 environment. First of all, I recommend changing the L3 external bridge to provider. I will link in the documentation to KBase articles that talk about the difference between BREX and provider. But essentially, this will allow you to create a real provider network for the external network, and we will be doing that in this environment with a VLAN. Okay, I'm going to go ahead and enable the Ceilometer agent in case you guys need some information from CloudForm's perspective. Otherwise, that is disabled by default. Now we get to the actual ML2 type drivers. So this tells Neutron what type of drivers to load on the back end. Right now, only VX9 is enabled. I mentioned we're going to use a VLAN for the external network, so we're going to enable VLAN. I'm going to go ahead and enable FLAT also in case you end up needing to use this one of the FLAT networks that we've already provided for one of your networks. So we've got those additional drivers loaded or to load. And then now we need to go out to the VLAN network ranges. Okay, so here is where we define a Neutron physical network and we map it to what VLANs we want to use. I'm just going to call this FizNet. FizNet1. I mean, this is an arbitrary label that you're creating at this point. You just have to understand what you're using so that when you refer to it later, you'll know what it's called. We're also going to provide VLANs, so we have a range of VLANs available between 121 and 124. So I'll go ahead and specify that. Next, we want to map that network we just created to what bridge we want created. OVS bridge mappings. So you can read the help here. We specified FizNet1, and as you see, that's in the documentation. That's why I use that as kind of a convention. But you can, of course, as I mentioned, use anything arbitrary here. All right, so we're saying that we want to create BREX on that network that we're going to use for our external network. So we want to create a bridge called BREX. And then we want to say on that BREX bridge, I want to map that to my provisioning network. So that is what the interface number 1 in the Pod 10 environment is. Of course, this might be ETH0, EM2, or whatever, based on a different environment. Next, we want to specify which interface is going to be used for the tunnel or the tunnels that will be created for the tenants. So in this case, we're going to use the ENP7S0, which is the other interface. I will enable these additional API, CloudWatch, and CloudFormations. And the last thing I want to change is this provision. So I'm going to turn off this provision demo, which if you come down here and you change some of the floating ranges and what image gets loaded and things like that, you can have a demo environment provisioned, and this may be appropriate for what you need. I believe you guys just use admin, so it doesn't matter. But it is important to disable that. If not, it will try to create your external network for you. Okay, so that is all we're going to change for now. All right, so the last thing I like to do before I kick off the install is do a diff of what I changed and what I originally generated from Packstack. So I can see that I changed my demo, I enabled heat, I've set my Neutron configurations as I need. Don't want to definitely make sure you didn't misspell anything. And that's pretty much it. I enabled heat and disabled Nagios, NTP, and so on. Everything looks good. All right, so I'm going to go ahead and start Packstack and tell it where that answer file is. All right, so we'll come back in about 20 minutes, and we should have an environment ready to go. And there we go. After about 20 minutes or so, We now have an environment up and going, so we can pull up the dashboard and continue the config from here. All right, we set the password to Red Hat, so I'll go ahead and log in here. All right, the first thing that we want to do is create our external network. So with version 7, and I believe even 6, you can do that from the UI. Some of the earlier versions require that you do that from the CLI. So we'll start out here. We want to create a network. We'll call this anything you want, but typically something like external. And by convention, you typically want to assign the tenant or project owner to be services. Everything may be just fine under admin, but that's fine. For now, we'll just follow best practices. And we are creating a VLAN external network. Now, this is the physical network that I talked about early on when we created PhysNet1. Again, this could be arbitrary, and you see that they had a label called default, which we could have used as well. So I'm using VLAN 123. If you recall, we specified a range. I happen to know that for this host, the VLAN 123 is set aside. Floating IPs are allocated for this blade. So you would maybe be using a different VLAN based on the blade you'll be using. Okay, I'm going to go ahead and mark that as an external network and create that. Okay, so we now have the network created. So the next step is to select it, and we want to create the subnet, which includes our floating IP range. So I like to call this one external as well. This is 10.11.171 for this particular system. And this is a real gateway that exists on that VLAN, which is .254. We do not want to enable DHCP. This is the floating IP range, so this will be a specified and allocated IP address. We want to specify the range. So 10.11.171 dot. Now in this case, I'm going to start with 160, and we're going to go to 189. So that gives us 30 IPs that we can use. The DNS server is 10.11.169.2, and you could specify multiple DNS servers if you need, but that'll work just fine. Okay, so we now have our external network defined and can now be consumed by users. So the next step I like to perform is to create a separate project and a separate user. For the Migration Factory demo, this may not be needed. Okay, next I'll create a user and place that user into the migration demo project we just created. Let's go ahead and start with just a very simple image. All right, I'm going to create a simple Cirrus image, and I'm going to paste the URL where I can get that online, tell it what the format is, and I'm going to make this public. That way any tenant can use that image. Image is now creating. And if you ever want to make sure the image uploaded properly, just make sure that you look at the size. If it was 0 bytes, then there was a problem. Looks like we're good now. So at this point, we can log out. Log in as the migration demo. All right, before we forget, one of the things we want to do is, for this demo, is just open up SSH and ICMP just to make sure we have connectivity. So you can add a security group. In this case, I'm just going to manage the default rules. And we're going to add 2 quick rules. So we'll add ICMP traffic, and we can leave everything else as default. And I'm going to add an SSH rule so I can connect remotely. There we go. we have one more thing to do from a networking perspective. We want to create our private network that this project tenants VMs will use, or instances will use, to connect to the external network. So if I look at network topology before I do anything else, we should see our external network. So this is what we created. So let's start by creating a private network. Everything is based on UUID, so it shouldn't matter. So this network address here is going to be what the tenants use to communicate with each other. This is a isolated, separate network, so other tenants cannot communicate directly with this network. So it doesn't matter what we use. So I'll just use the 192.168.100 network. I'm going to leave the gateway IP blank. It'll generate one automatically in that range. And I do want DHCP enabled, unlike the external network. And then I can go ahead and give it a DNS IP address to be able to resolve. And I don't need any host routes, so now I'm done with my network and my subnet. So the last piece is I want to connect those together. So if I start, or I head back over to the network topology, we'll see that we now have an external network, and now we have the new private network, but they're not connected in any way. So let's go ahead and create a router. What we're going to do is connect these together. So this is going to be the private router, or migration demo router, whatever you want to call it. And it's asking you here what your external network is. So it's going to automatically know to, essentially, we're creating a virtual router, and we want to connect one end of it. Think of it as the WAN port on a type of typical home router. So we want to connect that to the external network. So now the diagram's updated. Now we have a private router, which is connected to the external network. So the next thing to do is connect that to the private network on this side over here. So we can do that from this interface, add interface icon here, or we could go into routers and drill into the router and do it. And here I'm selecting what subnet I'm connecting it to on the private side. So here I've got my private network, IP address of that router interface on the private subnet. I'm going to leave blank, and it will automatically select one from that range. Okay, now I have my router connecting my external to my private network, and now any instances I bring up will be attached directly to the private network, and they'll be able to route out through this private network onto the external network. So let's go ahead and give that a try. In a typical scenario, you want to also create an SSH key pair, and that way you'll be able to SSH into the instance. But we're going to use the Syros image, which allows you to SSH with the username and password, so we'll go ahead and do that. I'm just going to call this a test. Tiny is fine for the Syros image. Okay, so this is good for access and security. As I mentioned, there's no key pairs available. I do want to attach to the security group default. The private network was automatically selected, and I don't need to specify anything else. Okay, now while that is spawning, we can go ahead and associate a floating IP with it. Now there's one step before association, is you have to allocate, but you can do that from right here. So we've got the external network pool defined and selected, so we will allocate an IP. So now we have this 10.11.171.161, and we're going to map that to this test private network of 100.3. Okay, now we're just waiting for it to spawn. Okay, so it's spawned. We see the internal IP address as well as the floating IP address. So we could take a look at the details here. We can see the security group. We have port 22 open. So now let's try to connect. So we have 161 IP address. Let's see if we can ping it. And we can ping that address. And now let's SSH. The user is Syros. And the password is CubsWin. And now we can see we're on that instance. We have the IP address, and I was able to SSH to it. If I were to log off of the blade, there was my tmux. Now I'm on my MacBook, and I can SSH to that IP. so I can get to this from outside as well. In this section, I'm going to talk about a scripted method that I've put together for deploying OpenStack environments using PackStack. This is for the Pod 10 environment designed to be used by the Migration Factory. So far we've walked through how to manually configure a system and go through the options for PackStack. What I'd like to do is go through a way that this can be completely automated from a full brand new system build. So let's start by connecting to a system that has been installed with RHEL 7.2. And if we take a look at the IP addresses, we'll see that we only have a provisioning interface configured. If you recall earlier in this video when we talked about the tunnel interface, which was ENP7S0 for these blades, that is not configured. I'll show you that the script will configure that. The repositories are the default provided by Cobbler, which are these core repos. And we talked about in the previous sections of this video that needs to be disabled. That will be done as well. So let's take a look at the script itself, and I'll walk through very quickly. We won't spend a whole lot of time, but one thing I'd like to mention is that these systems, when they get provisioned through Cobbler, they get configured with an auto mount. So that is, if you just take a look at /fileshare, tab, you'll see that there's an NFS mount with these directories available. So if we go to scripts and just drill down to OpenStack PackStack, we'll see that there's a couple of scripts in here. So the main script we're going to run is this deploy openstack.sh. There are two other files that are used by this script. So we have scenario and we have common libraries. So I'll walk through the common libraries just very quickly. This is just some helper functions that we run all of the commands through. So you'll see here there's a debug check, a verbose check. So if we run it with debug, it's going to give us a lot of information about each command. Whether you run it through debug or verbose, it's going to do some additional checking down here. It's going to look at the return code. If verbose is on, it's going to tell you what the return code is of each command. If there is something that's not successful, meaning it's a non-zero return, it's going to stop and prompt you whether you want to retry, continue, or stop that command. Now this will happen regardless of the verbose or debug. This is going to happen on any command. So the script is automated, but if there are any errors, it will stop. And that's pretty much it for common libs. If we take a look at the scenario all-in-one, this is really the only file that needs to be modified if you need to deploy an additional blade. So if we take a look here, this is where we can set verbose and debug. For this initial run, I'm just going to leave verbose on so we can take a look at what that output looks like. But these are the variables that you'll want to set. So I've set some defaults, but you can change the username. Now you'll see here the tenant name is set to the same as the username, so this can be anything that you want. For the Migration Factory, you may not even need a username or tenant. Admin may be just fine, but I do go ahead and walk through the workflow of setting up a user and tenant just to make sure that we can bring up an instance and assign a floating IP and so forth. The password here is what gets set for everything, for the admin username, for the user password, as well as it is injected into the RHEL guest image so that you can log in at the console if you need to. The RHEL OSP version, this is important. If you recall, in the earlier section of the video, we talked about ROS release, which will allow you to access the internal engineering repositories and enable the version that we're going to be deploying. This is the output of ROS release-L. As of this date of this recording, we can go back to version 4 and all the way up to version 8. So in this demo, I'm going to deploy version 8 onto this blade. So I'm going to go ahead and leave that as the option. Currently, we have a dedicated NFS storage server, and that is where this IP address is pointing. You'll see here this NFS export is going to use the RHEL OSP version as the actual export mount point. In this case, we're not passing any additional options, but here's where you could add async or something else. The floating IP is another thing that you'll have to change. Make sure that the available floating IPs are specified. But in this case, I'm just doing a demo run, so I'm going to go ahead and change this to just a 10 IP address range. The rest can be left alone. Now, if, for example, there's a different network that we're going to be using for the external floating IP range, and we have to change that, let's say we have 10.11 172, for example. Well, we'd have to change that here. We'd have to also go and change the network here, and we'd have to also change the gateway. So just make note that I've put all of these in one easy-to-access section so that you can make all those changes at once. Okay, so I'm going to undo that. We're going to go back to what we had. This is our floating IP range. The rest of these, if there's a different VLAN that I've set aside for you, I would let you know what that is. But that's really all that you have to change. Now, I'm just going to scroll down through the rest of this very quickly. There are some additional variables that are determined. For example, the host IP is gathered based on the external interface. If you end up running this after OpenStack has been configured, that IP address has been moved from the external interface to BREX. That's why we have this if check here. This host ID is basically grabbing the last number of the IP address, so the last octet will be used for various things. For example, it's going to be the private network that's created, so we'll have a 192.168. In this case, we SSH'd into .40, so this would be 40.0 would be the network. And that is pretty much it for the networking. The last section here is about images. So the first thing we do is we decide whether we want the images that we upload to be public. Now, I do recommend that we do this. If this is set to true, then the images below will be uploaded as the admin user and made available to all tenants. For this test environment and the migration functionality, this is going to be just fine. If there's a case where you want a tenant created that is going to be uploading their own private images, you'd set this to false, and then the images would then be uploaded as that user into that tenant rather than as admin. But the rest is pretty self-explanatory. We have the image URL. In this case, Syros will be grabbed from this location online. The Syros name, which will be used in Glance, will be dynamically generated based on that URL. If you wanted to use something more specific, you could set that here instead. Same with Windows. Now, this Windows image is rather large. I believe it's around 16 gigabytes. So rather than pulling that down online, I've actually just put that onto that file share. And then again, the Windows name is determined dynamically off of that file share name. And because these images are so large, I've added this variable here to determine whether you want an instance built off of that image. It does take a very long time. In fact, it takes so long that Nova times out when trying to build it. So I've set this to false. Now the image will still be uploaded and still be available in Glance, but it's not going to build a test instance. This last section is if you want to use the latest Railguest image, you can set this to true. Otherwise, it will default to using the one available on the file share in the same location. And then lastly, the image name will be determined based on that this URL here. And if you set the install latest to true, it will ignore this URL, but it will still use the URL to generate the name. Okay, so that is it for the scenario. I did make some changes, so I'll save that. And lastly, we have the actual deployment script itself. There's a lot of details in here, so I'm going to walk through this fairly quickly, but I do want to just walk through the workflow. What I'm going to do first is jump to the bottom of the script and show what happens when the main part of the script is called. So we have essentially these functions that are called, and this is basically the different steps of the workflow. So the first thing we're going to do is prepare the host. We're going to make sure that, and I'll walk through what we do, but we're going to make sure that the networking is set up, that the repositories are disabled, and then install ROS release and enable the version that we need. Once that's complete, then we're going to configure Packstack. So we're going to essentially automate through the steps that we walked through earlier in this video. We're going to enable the options we need and call Packstack, and then that is the end of that function. The next function is going to perform the administrative tasks. So this includes creating the user, creating the tenant, creating the external network, and if you've set the images to be public, then this next function would do that as admin. If you have set that to false, this would create the images as the user. Then we perform the post-install user tasks. So this would be creating the networks, creating a router, modifying the security group, and all of the standard workflow steps needed to prepare a tenant environment. Next, we build some test instances. So this would be the Syros and the Rail images would be used to build OpenStack instances. And if you set the Windows build to true, it would also build the Windows instance as well. The last step is enabling a Cinder NFS backend. This is not done by Packstack. This is something we'll have to do post-install, so I've automated those steps as well. Okay. So jumping back to the top, we start out the script here. Well, first of all, we're going to log everything. So regardless of what happens, you'll be able to refer back to the log to see if there are any errors, or just to refer back to the commands that were run in case you need those. So we're going to source these two files, first the common library and then the scenario. Okay, then we just do a quick check to make sure that we've obtained the IP address of the controller properly before exiting. So then we start our prepare host function. Now you'll see that a lot of these commands start with CMD. If you recall, that is available in the common library function. And this is essentially going to inform every step of the way what is happening. If there is debug set, it will actually pause before executing the step so that you can confirm with enter before you move forward. Okay, so as I mentioned, we're going to disable Network Manager, which is necessary for Packstack. Next, we're going to configure the tunnel interface. So this is, again, where the host ID is used. So I talked earlier in the video about this tunnel network does not need to be routable, but it does need to be available. So that's what we're doing here. We're just going to use 172.1.6. In this case, it will be .40.40. Then we move on. We disable the cobbler repos. We install ROS release, as I mentioned. Here's where we disable the repos after we install ROS release. We've got to make sure and do that in order, and then enable the version that we need. Okay, then we're ready for the actual Packstack install portion. So again, we're going to just install Packstack itself, then generate the answer file. And here we're going to set options based on what I recommended in the earlier part of the video. So this is setting the different compute, controller, and network hosts, which in this case would be the same. Again, here's the variables. If you wanted to specify those separately, you could do that, or multiple. If we've set debug, we'd set debug in Packstack as well. That way it saves all the Puppet manifests. And then we're just going to go through and make the recommended changes that I highlighted in the video. So we set the NTP server, and then, as I mentioned, the vital part of this configuration is the actual Neutron settings, and that's what these are here. And so we've got the external interface, the tunnel interface, all of those are variables. Okay, so moving on. Once we are done editing the answer file, we run Packstack, and then when that's complete, we restart the services. And then we move into the post-install admin task. So this is where, so I've tried to make this convenient so that we're checking for these objects before we try to create them. Same thing with the user. We're going to only create the user and add the roles if that user doesn't exist. And then the external network and so forth. So here's where the external network is created along with the external subnet. Okay, at the end of this function, we create the user Keystone RC. So this is providing the ability to source this file as the user and perform actions within that tenant that are non-admin. Then we move on to creating the images. And one thing to note is there was an option change to what used to be --is--public. In RHEL OSP 8 is now, or Liberty, is now --visibility. So what I've done is I've created an array with all of the versions that use the old option of --is_public, and then the new versions which use visibility. So I'm just doing a quick check here. Based on the version you've set, that option will then be set to either visibility public, or it's going to be set to is public based on the option you set in the scenario file. And you'll see I've also made an assumption that if you are setting it to public, and we're within the correct version, then you want to source the admin RC file so that this can be done as admin, since only admin can make images public. If you have not set that public option, then it's going to source the username, and that's where that decision is made. Okay, once we get past that, we're now ready to start creating the images. So just as I did above in the previous function, I'm going to check to see if the image is there before trying to create it. And if it's not there, then we'll go ahead and pull down that image from the URL and then create the image into Glance. For RHEL, it's slightly more complicated. If you recall, I talked about the option for the latest, which is this here. If that's true, we're going to actually do a yum install of RHEL guest image 7 and then copy that over to temp. If that option is not set, then we're just going to copy it from that URL location. In both cases, we are installing libguestfs tools, and then we're going to do a vert customize on the image, whether we got that from the URL or from yum install. And we're going to set that to whatever you specified as the password in the scenario file. So that's very helpful when you're trying to get onto the console of the RHEL instance and perhaps the floating IP is not working or something. and you want to log in as root. And then lastly, we'll just create the image. This last section here within the function is the Windows image. Now this will take quite a while. As I said, it's 16 gigabytes, so that will load that into Glance and take about between 5 to 8 minutes. It just depends. Okay, the next section is the post-install user tasks. So this is going to be creating the key pair, modifying the security groups, and here I'm just checking the security group rules exist before I attempt to add them. And if it's not there, then we go ahead and add it. If we have Windows build set, then we're going to open up 3389, which is the remote desktop port. Otherwise, we won't do that. Then we move on. We create the network, the subnet, the router, and we connect that to the external network. And that is it for that function. Then we move on to building the instances. And this is pretty straightforward. We're just going to source the Keystone RC for the user and then start building instances if, again, they're not there. Okay, so we specify the flavor, the image name, and we start up a Ceros image, a rel image, and again, if we've specified Windows build true, then we'll build the Windows image. Then at the bottom here, we just loop through Nova list, and we're looking for the keyword build. If we see build, we know that it's still building an instance, and we just sleep for 2 seconds and continue waiting. Eventually, either the instances will build or error out. In the case of if Windows is not completed, it may time out, and then it will eventually move past this loop. But there's a few more details here. So we're going to grab the instance ID and port ID, which will be used later. We're grabbing the router ID so that we can understand what the namespace is, so that we can try and ping the internal addresses of those instances. We'll then grab what the private IP address is for each one of these instances and then ping them and make sure that we get a response. And that's what we're doing down here. And so we're going to run the IPNetNS exec against the network namespace and then ping it. Just make sure that those internal IPs are up. Once that's successful, then we start assigning a floating IP. So we're going to use some of the variables we grabbed earlier, the port IDs. We're going to create a floating IP for each one of these instances, and then we're going to associate them. Then we're going to ping those once they come online. And so we have another loop here that's going to wait for those floating IPs to show up within Nova list. And that's what we're doing here. And then lastly, we're going to ping the floating IPs. And this will tell us that networking is fully functional. I'm also going to echo out what IPs belong to which instance. That way, when you're looking at the log or the console, you can quickly understand which IP has been associated to which instance. Then we'll display the status so that it gets caught in the log so we can go back and double check. And then once again, we'll generate VNC consoles so that we can easily bring up the console within a web browser. Okay, the last section executed is enabling the Cinder NFS backend. So what we're actually doing here is following this KBase article on how to configure an NFS backend for Cinder. So this is assuming that we've used a Packstack install, which we have done in this case, or we are about to do, and essentially configuring SE Linux and the actual NFS share and enabling the Cinder options that we need. So this is what is followed. If we go back, we take a look at, there is another check here. So for versions 4 and 5, we don't have multiple backends enabled. So we have to set one option, and we're actually going to set the NFS option as the default. That's what this here is. If we are using anything other than those versions, then we're going to actually enable an additional backend of NFS. And so that's the article I was just showing. For versions 4 and 5, we're just following the upstream documentation for enabling the NFS driver, which is really very straightforward and simple. Okay, so the rest of this function just sets the different options that we need for Cinder and creates the Cinder type of NFS, creates the backend, and we restart the Cinder service and then wait for services to come back up. And then we create a test volume, and the NFS storage can be checked to make sure that that's there. Okay, so that is it. I'm going to go ahead and execute this now. Again, one more time. We don't have networking set now, but that will be set. Now, as before mentioned, you should always use Screen or Tmux. In case your session becomes disconnected, it will continue to run in the background. Okay, So I'm going back to my home directory, and I'm going to go ahead and execute deploy OpenStack. Okay, I'll return when this is completed, and we'll review to make sure that everything was configured properly. Okay, and here we see the scripting continuing after the packstack run. You'll see some of those warnings were the OpenStack client, which are easy to ignore. Those are just warnings. Now we're on to the image section. We're starting to upload those. Here during the rel section, we're installing libguestfs tools. And then once we modify the actual guest image to inject that password, that will take a few minutes. What it's actually doing in the background is spinning up a VM temporarily to make the modifications and then shutting it down and saving that image. So this might sit here for a few minutes. Meanwhile, what we can do is take a look at the actual Horizon interface. We can log in with the username. We could log in as either admin or the user that we specified, which was migration-demo, and the password of Red Hat. But we could take a look at some of the actions that have taken place. So we are logged in as admin. Because I've added admin to both the migration demo project, and of course he's part of his own project, right now it logs me in as the migration demo. So if I take a look, I will see that as of yet, there are no networks set up for the tenant user yet. So we see that topology is essentially empty. There's nothing there. But if we switch to the admin project and then take a look at admin and then networks, we actually do have the external network. So it's been deployed. If we drill into it, we'll see that we do have the subnet specified. We already have some agents being fired up. If we take a look at the subnets, we'll see that our floating IP range that we specified in that scenario file has been set. So we don't have any instances yet. The images are just now being uploaded. So if we take a look there, we should see the Cirrus image. There it is, and in fact we see the scripting has moved on to the Windows image. There we go. We're creating the Windows image now. If I were to scroll up, you'll see here's the Vert Customize on the rel image just before it was uploaded. So again, we've got Cirrus, we have a rel guest image. We'll see that they are all public as well. And it is in the middle of uploading the Windows image itself. Okay, so we see the upload of the Windows image took about 2.5 minutes. And now we're starting to run the post-install user tasks. So this is modifying the security groups. We're going to build the networking and then move on to building the instances. So if I switch over, we should see the Windows image is complete now. We can see that it is 16 gigabytes. And if I refresh, we'll see that some of the data here isn't completely populated. There we go. And now we see it. So at this point, I can move on to looking at the migration demo tenant project instead of as admin. There we go. So now we're looking at the project, and we can start taking a look at the topology of the network. All right, so we see we have our external network with our private network. We have our router in between, and now we can see that instance just popped up. Oh, there's the second instance. Oh, there we go. We can see the external network, the migration demo router, and the additional instances popping up. And if we click on these, we can see the details about them. This is new in RHEL OSP 8. Before, this used to be a flat network topology. So now we have this nice, fun, little wobbly, interactive representation of the network. This is similar to what we saw with the heat resources as they popped up online. But if we just switch over to the flat view of the networks itself, we can see we have the migration demo, 192.168.40, and then of course we have the router as well. Okay, now we've moved on to pinging the instances. These are the floating IP addresses. We can see those pinged just fine. Now we're taking a look at the services. And now the script is completed. And we can see the last action here was the volume that was created. So we'll take a look at that in a minute. So now let's take a look at our instances and make sure everything came up properly. Okay, so there are the two instances that we built. We have RHEL on the 192.168 network internally to this tenant with the .4 address, and then the floating IP address of .222 on the 10.11.171 network, and then Cirrus the same with its private and floating IP. So let's take a look at the console of the RHEL system. We can see here we have the host name assigned properly, and we can log in with that injected password. We can see the matching internal private IP, and we should be able to get out. Okay, that looks good. So the next thing we want to do is see if we can connect to this system. So that IP address, if you recall, was .222. So we'll SSH in, and we're going to have to specify the migration demo private key that was created during the script process. And then we need to use the cloud user. And we're in. Again, same IP address, and we can ping out, and connectivity is good. Next, we can test the Cirrus instance, but let's do that from my actual MacBook rather than from the blade itself. And we'll SSH in because we don't need a key. We'll use the Cirrus user. That was 221. And we're in. There's the 192.168 address. And we can ping out to the internet. And we can get in from outside as well. The last thing we want to do is double check and make sure the volume is created properly. So here we have the NFS test volume that the script created with the NFS type. And if we take a look at the details, this will match what we saw at the end of the script, which was this ID of A25C. All we really want to do is make sure that it connected to the right storage. And of course, a typical user wouldn't have access to the backend storage. We happen to, though. So let's take a look in the NFS share. And there it is. So we do have the volume. It's created on the NFS storage. So that wraps up our scripting automated method to deploy an OpenStack environment using PackStack. I hope this was helpful. If you have any questions, let me know.